So welcome to Physics Form 4, a chapter on photoelectric effects. Today we'll be looking at factors which do affect the photoelectric emission, or the rate at which the electrons are going to be emitted from a metal surface. Just from the prior knowledge, we saw that if we are going to have a metal and then we radiate that metal with radiation of a certain wavelength and a frequency, if the frequency of light is able to go past what we call the threshold frequency, which is denoted as F0, then we are going to have the radiation penetrating through the metal, and then it is going to eject electrons. So we have the electrons there. So if this light is able to penetrate the metal surface by meeting all the conditions necessary, we are going to have the electrons being excited, and then eventually they are going to be emitted from the metal surface. So those now are the ejected electrons out of the metal surface, and now that is what we call photoelectric emission or photoelectric effect. The general term it is photoelectric effect. To emit, it is to cause the electrons to move out of the metal surface. So we talk now about injection of electrons. Injection of electrons. So from there, we also talked about something to do with the work function, and we say that work function is directly proportional to the threshold frequency. But now you have to understand that when we are talking about work function, we are talking about the work that must be done for the photoelectric emission to occur. And this one can only qualify when the threshold frequency is met, because we know that light has its own frequency and a wavelength. So if the frequency of light is less than threshold frequency, then here at this scenario there is not going to be any photoelectric emission, because for the photoelectric emission to occur, with the light, the radiation of the radiation should have a frequency which is more than the threshold frequency, and then the threshold frequency is what? It is a minimum, that minimum amount of frequency that a given radiation is sufficiently enough to cause photoelectric emission, or to cause electrons from a metal surface, any metal surface to occur. Different metals, they have different work function. So, like for example, the way we can radiate light or radiate a given type of radiation on a metal surface of aluminium to emit electrons, it is not the same way we can do to magnesium and the other metals. Each metal, it has its own work function. So you can find that if you are using a light of a given wave frequency to emit electrons in a certain metal A, then for metal B, we can either increase the intensity or reduce the intensity. So it varies. So from there, having that knowledge with you, we can now go to the factors affecting photoelectric emission, and one of the factors is intensity. Intensity of radiation. When we are talking about intensity of radiation, we can think about the radiation itself in terms of its frequency and the speed before hitting the metal surface. So if, for example, we talk about a light radiation of high frequency, if we talk about radiation of high frequency, then it means, as you know from the waves, if the wave has high frequency, then the wavelength is going to be what? Short. The wavelengths are going to be short. A wave like this, it means the wavelength is from one point, because when we are defining a wavelength, we have to know that we are moving from what? Either one crest to another crest, or from one trough to one trough. That is the wavelength. So if we can compare the two, you find that the wavelength here is low, then the wavelength here is large. So this is the radiation moving at high frequency. This is the radiation moving at low frequency. So intensity of this radiation will be higher compared to the to the letter. So in this case, we say that if radiation has high frequency, then its intensity is also going to be high. Or in other words, intensity is directly proportional to the frequency of radiation. And if light has high frequency, then it means if that frequency has gone past the threshold frequency of that material or metal surface, it is able to eject electrons. If light has high intensity, then it means per unit area, the beam reaching the metal surface per unit area is what? It is strong. And if it is, then we are going also to eject as many electrons as possible. If it has low frequency, it means the intensity is low, hence the electrons going to be emitted or ejected out of the metal surface is also going to be low. So that is the factor number one when we talk about factors affecting photoelectric emission. Then we have number two. The factor number two we can talk about now in terms of the frequency itself. In terms of frequency itself.